So in this section we are going to talk about bases. You can think of bases as being the opposite of acids, although maybe that's not quite correct, but it's close enough. Even though they're the opposite of acids, they're not quite as common in popular culture as acids. I imagine that pretty much everybody in this lecture has heard of acids at least once. Bases, maybe you have, maybe you haven't. The way to think about bases is that they neutralize acids. And since acids are materials that release H pluses, bases you can think of as materials that get rid of the H pluses that are released by acids. And you'll see that more formally in a few slides. How do they neutralize acids? We'll talk about that in a little bit. But just right now, just think of bases as being materials that neutralize or get rid of the H pluses that are created by acids. Tums antacid, if you've ever taken Tums antacid, that contains a base that neutralizes the acid in your stomach. One definition of a base, and this is not a great definition, but it's a great starting point. One definition of a base is it's a material that releases OH minus ions. Sometimes these are called hydroxide ions. Material that releases OH minus ions when it's dissolved in water. Sometimes OH minus is called a hydroxide ion, as I mentioned just now. This material here is an example of a base. It's called sodium hydroxide, in case you haven't seen it before. Na stands for sodium, which is part of its name, and OH, as I just mentioned, is called a hydroxide ion. So when these two things are connected to each other, the material is called sodium hydroxide. If you mix sodium hydroxide with water, if you dissolve it in water, these things disconnect from each other. The sodium turns into a sodium plus ion, and the OH, actually those two atoms remain attached to each other, but they have a negative charge, and this is called a hydroxide ion. Because sodium hydroxide, this stuff over here, when you mix it with water, releases an OH minus, it meets our definition of a base up here, because our definition was a material that releases OH minus. So sodium hydroxide is a base as long as we follow this definition up here. And it is a base. This stuff over here is a base. Okay, so this is sort of the classic example of a base. It gets used over and over again in chemistry and biology, probably sometimes in medicine as well. This is sort of the base that everybody breaks out when they're showing an example of what a base is, although there are other bases. How do bases neutralize acids? Well, here's an example. If you take hydrochloric acid, and this is the one I wanted you to memorize from the previous section, if you take hydrochloric acid and mix it with sodium hydroxide, what you end up with is the sodium ion disconnects from this guy. The sodium ion actually ends up more or less attaching itself to the chloride ion, and sodium and chloride make this stuff over here. They make table salt. So those two things, when you mix sodium hydroxide and hydrochloric acid, you do end up making table salt. And the hydrogen ion that was going to be released by the HCl, this H plus over here, ends up attaching itself to the OH minus, because this guy has a negative charge, this guy has a positive charge, they're attracted to each other, and you end up with HOH. Hopefully this will look familiar to some of you, although it's written in a weird way. What is HOH? Well, it's water. I just wrote it in a funny way just to show you that when you mix HCl with NaOH, what you end up making is you make water and you make table salt. And so the question originally was, how do bases neutralize acids? Well, this is how they neutralize acids, more or less, is that the OH minus here basically soaks up the H plus that's released, and the two of them together end up making water. And just by that magic, the H plus disappears, because the H plus was used as a piece to make a water molecule. So that's how bases neutralize acids. They soak up the H plus and they convert it into water. So in a more general sense, when you have an acid and you mix it with a base, if you mix the correct amounts with each other, the acid and the base together will make water, and they will make some type of salt. And if you remember, they don't have to make table salt. In this case, they do make table salt because the only thing you have is sodium and chlorine, and that's going to make sodium chloride. But they don't, it depends on the acid and the bases that you are mixing together as to what type of salt you will get out. It won't always be table salt. As an example, this is hydrochloric acid mixed with a different base. This is called potassium hydroxide instead of sodium hydroxide. But the basic chemical reaction is the same. The K turns into K+, and it attaches itself to the chlorine, and it will make a salt. This is a different kind of salt called KCl, sometimes called potassium chloride. But then the same thing happens again. The OH from the KOH, this OH here, will attach itself to the H+ ion and make water. So here's just a different example of an acid and a base neutralizing each other, and they neutralize each other to make water and some type of chemical salt. So one of the punchlines, or one of the things I want you to be able to do, is if I show you a chemical reaction like any of the ones above, except I hide the stuff to the right side of the arrow, you should be able to know that the acid and the base are going to make water, and they are going to make some type of salt. And you should be able to figure out what type of salt they're going to make. Over here, the H and the OH are going to make water, and the K and the Cl are going to basically attach to each other and make KCl salt. Over here, it's going to be sodium and chlorine attaching to each other to make sodium chloride. But it doesn't really matter what I give you on the left side of the arrow. As long as you know that it's an acid, and as long as you know that it's a base, and I will try to make that as clear as possible, then you can figure out the stuff that's going to be made on the right side of the arrow. You can figure out that there will be water made and some type of chemical salt. So there are three bases that I want you to know. In the previous section, I asked you to memorize one acid, and that was hydrochloric acid. There are three bases that I want you to memorize. There's sodium hydroxide, which I just showed you. It's sodium and a hydroxide ion. There is lithium hydroxide. Again, this shows up somewhat frequently. Sodium hydroxide shows up the most frequently. Lithium hydroxide and the next one, potassium hydroxide, show up less frequently, but they do show up. So I want you to realize that all three of these materials here are bases. And you can see that they all have OH. And when you mix this stuff with water, the OH minus will disconnect from the potassium or from the lithium or from the sodium, and because you're releasing OH minus, you will make these materials are a base. So there's a problem, however, and as I mentioned in a previous unit, there always has to be some type of problem, otherwise it wouldn't have a job. The problem is this. In real life, there are other materials other than these types of things that neutralize acids. In other words, there are bases out there in this world that neutralize acids, but they don't have OH minus in their formula. They don't have OH at all in their formula. So, because there are bases that can neutralize acids but don't have OH in their formula, our original definition of a base, which was something that releases OH minus when it's dissolved in water, isn't the best definition. We need a better definition to describe what a base is, and that's what the next slide is going to be about. Because our original definition of a base wasn't the greatest, because there are other materials that behave as bases but don't have OH minus, the best way to introduce the idea of giving a better definition is to show you a base that actually doesn't have OH in its chemical formula. The classic example of this is a chemical called ammonia. I'm sure many of you have used ammonia before, at least cleaning things around the house. The formula for ammonia is NH3. And hopefully by looking at this, you agree that this formula does not have OH in the formula. So how does ammonia, even though it doesn't have OH or OH minus, it is a base. So how does ammonia actually neutralize acids? Well, here's the chemical equation of ammonia neutralizing hydrochloric acid. Here's hydrochloric acid over here on the left. This is the formula for ammonia. What ends up happening, and remember, to neutralize an acid, basically what this material has to do is to somehow get rid of the H pluses that are released by the acid. And the way that ammonia does it is the whole molecule actually sops up the H plus. So this chlorine and the H plus disconnect from each other. The H plus actually goes over to the NH3 and it gets soaked up by the whole NH3 molecule. The NH3 molecule turns into something new called NH4 plus. The reason is it started out with 3 hydrogens, but it received another hydrogen from the HCl, so it turns into NH4. And not only did it receive another hydrogen, but it received an H plus. Because of that, the NH4 is positively charged. It's positively charged. The chlorine that got disconnected from the H is negatively charged, and there it is. This stuff over here, the NH4 plus, is not ammonia. It might look like ammonia, it might have a similar formula to ammonia, but it is not. It is called ammonium. It's called an ammonium ion. But hopefully you can appreciate that this HCl was going to release an H plus. However, the NH3 basically soaked it up and absorbed it, if you want to think about it that way, and turned itself into NH4 plus. And that's how the ammonia neutralizes the acid. If this wasn't here to soak up or absorb the H plus, you could think of the H plus as still being able to run around off to the right here in whatever liquid they're mixed up in. However, this ammonia is here. It is able to absorb the H plus. Because of that, the H plus doesn't get to run around and behave like an acid, and so the ammonia on the left here neutralizes the acid and turns itself into ammonium. So that is the classic example of a base that does not have OH in its chemical formula but still neutralizes acids. There are others. We won't really go into them in any detail in this unit, but you should be aware that there are other bases that don't have OH minus as well. So, if you remember from one of the previous sections, we said that an acid is a material that releases a proton or releases an H plus. Better definition of a base is something that accepts a proton or accepts an H plus. So this is basically a more all-encompassing definition of what a base is. In other words, this definition doesn't say that you need to have OH minus as part of the chemical formula. But what it does say is, as long as the base or some piece of the base accepts protons or absorbs H pluses, then it's a base. And this stuff over here does that just fine. It accepts or it absorbs protons, if you want to think of this thing as a proton, or you can think of it as accepting or absorbing an H plus. Either way, this material, this ammonia, meets the definition of base that's shown in this bullet point that I'm circling. So, and that again, that's just shown here. The HCl, hydrochloric acid, mixing with ammonia turns into ammonium. So the H plus doesn't get to run around all by itself, and it turns into a chloride ion as well. What you can think of is you can think of the acid as being the proton or H plus donor. This is the guy that actually donates the H plus. The base is the material that accepts the H plus or accepts the proton. So sometimes people will call acids proton donors or H plus donors, and sometimes people will also call bases as proton acceptors or H plus acceptors. And I'm just trying to show you who the acceptor is. This is the acceptor of the H plus, and this is the donor of the H plus. So this is the acid, this is the base. And again, just to give you a formal definition, acids are materials that donate protons or donate H pluses to bases. Bases are materials that accept protons or accept H pluses from acids. Those are relatively formal definitions. Again, there are other definitions of acids and bases that very often make the heads hurt even of chemistry majors, so we are not going to go into those. These are probably very good definitions of acids and bases, and they're certainly good enough for our purposes.